In topic 3, we're going to talk about the third exponent rule for multiplication, which is called the products to powers rule for exponents, okay? And it's exactly what it says if you really think about it. It says when a product, now the product must be in parentheses, keep that in mind. When a product is raised to a power, raise each factor of the product to that power, simplify as needed. So in this symbolic example, we have the product AB. It is in parentheses, it's raised to the n power. What we do is we take A and raise it to the n power, and then we take B and raise it to the n power. So let's go ahead and just jump into our examples here. So for part A, we have 3x in parentheses to the fourth power. That means the 3 and the x are going to be raised to the fourth power. So what we can do is we can take 3 to the fourth and multiply it by x to the fourth. And anytime you have a numerical base, you want to go ahead and evaluate that. So we do need to jump over to the calculator, and we want to figure out what 3 to the fourth power is. Well, we type in our base of 3, the caret button, and the exponent of 4. We get 81. You could also do 3 times 3 times 3 times 3. Definitely 81. It's going to save you time if you learn how to type in the exponent, though. So what we have here is 81 x to the fourth. Now, what's really happening here is we really have 3x times itself 4 times. So we have 3x times 3x times 3x times 3x. We'll notice we have 1, 2, 3, 4 threes. We have 1, 2, 3, 4 x's. So we can use this products to a power rule as a shortcut. Again, that's the whole reason for these exponents. They give us these nice these exponent rules, they give us these nice smooth shortcuts that we can use to save time and energy. Okay, next up we have for part B, we have negative 5x squared to the third power. So again, we have a product in parentheses. We're going to raise that to the third power. So I've got negative 5, keep it in parentheses, to the third power. We have x squared to the third power. Now, as far as negative 5 to the third, when you have a negative in, like a negative base inside parentheses, the exponent tells you if that's going to be positive or negative. If you have an even exponent, that would be positive. If you have an odd exponent like we have here, that tells you that this product is going to be negative. So when you go over to the calculator, you do have to be careful. You have to use those parentheses. If you forget to use the parentheses, it may or may not give you the right answer depending on the exponent. So we're going to go parentheses, negative 5, parentheses, caret button, 3, and you should get negative 125. Now, you could also do negative 5 times negative 5 times negative 5, but that's a little lengthy, and the whole point of these exponent rules and the whole point of exponents really are to kind of save us time. So either way, you're going to get that negative 125. So hopefully you're starting to really believe what I'm showing you. Let's go ahead and simplify down here. Okay, so we know that the negative 5 to the third power is negative 125. But now when we look at this variable portion, this we have to use the power rule. Notice you have an expression. Wow, we have an expression with an exponent. So we have like a little exponential notation expression, and that expression itself is raised to another power. So when we have x squared to the third, we want to keep the initial base of x and we want to multiply the exponents. So the x portion is just going to be x to the sixth. So this simplifies completely to negative 125 x to the sixth power. So do know that when you have the products to a power rule, you'll also be doing the power rule inside. Okay, last up we have negative 2x to the fourth squared. We have a product in parentheses raised to a power. We're going to take each factor of that product and we're going to raise it to that power of 2. So I'm going to take negative 2 in parentheses and square it. I've also got x to the fourth squared. Now, when you have the negative base in parentheses, the exponent tells you if it's going to be positive or negative. If you have an odd exponent, you get a negative product like we had in part B. However, if you have an even exponent, you will get a positive product, and you have to be very careful with the calculator. Here, you absolutely must type in the parentheses, okay? So let me just prove to you why you have to type in the parentheses. So let's say we do negative 2 in parentheses squared. We should get positive 4. But if you forget the parentheses and you just do negative 2 squared, it is going to give you a negative, okay? Those parentheses matter. So if you have a negative base, whether it's in parentheses or not really truly does matter, okay? In this case, we started out in parentheses. We need to go ahead and evaluate with those parentheses, okay? So regardless, we should be getting positive 4 here. So we have positive 4, and then just like before, we're using the power rule. We have an exponential notation type expression, so an expression that already contains an exponent. That expression itself is raised to another power. You want to keep the initial base, and you want to multiply the exponents. So x to the 4th squared becomes x to the 8th power. So just be really careful. Watch your signs when you have a negative base. And then just know that when you're doing the products to a power rule, frequently you'll have to also do the power rule. Okay. So these are the three exponent rules that we're going to use for multiplying. You've got the product rule, which just tells you that if you're multiplying two expressions, so think product, multiply, when you're multiplying two expressions with the same base, keep the base, add the exponents. The power rule says if we have some kind of exponential expression that is then raised to another power, we keep the initial base, we multiply the exponents. And then when you have the products to powers rule, you have a product in parentheses raised to a power, you apply that power to each factor of that product, and just know that you'll have to generally incorporate the power rule, okay? So make sure you study and practice and understand the difference between these three rules.